First, a little bit about me. So you already know, my name is Alf Solli. I'm 31 years old, married with kids, though my wife is very much grown up. I've been a Zabbix user and administrator since somewhere around version 1.4 in 3 different companies. Companies ranging from national telecommunication, oil and energy industry, and last and currently Eltele, which is a relatively large ASP, ISP. Eltele is a company that has 10 gigabit backbone through the entire county. And being from the northern part of Norway, and for those who have been there, that's actually saying something, since, like I said, those who have been there, you know that the terrain is rockier than all the Stallone movies combined. A little bit about Eltele's Zabbix installation. It's not much very unique about it. We're monitoring around 1,100 devices, roughly 87,000 items, 38,000 triggers, 40 front-end users. We're delivering front-end access as a service for our customers. And despite that relatively large number, we managed to get away with around 230 new values per second. This is, of course, just due to careful planning and tuning of the templates. Our philosophy is you don't monitor stuff you're not going to need, and not more often than absolutely necessary. The installation is, for the most part, highly redundant. We're using high availability and using OpenAIS on SQL servers, Zabbix servers, and the front end. I'll be showing a few slides illustrating that soon. In addition to that, we're having 6 proxies. Those are for either large customer networks, where it's, from a management point of view, makes sense, or otherwise just restricted networks. From the above metrics, it's divided into roughly 70% Cisco devices, switches, routers, firewalls, 15% servers, mostly Windows-based, and the remaining 15 are environmental sensors, IP cameras, UPSs, and other odd kind of equipment. So we have a rather blurry picture of the front end. It's clustered in every way, like I said, high availability, master standby setup on the load balancers, multiple active masters on web servers. For the web servers, we're using LVS. And the database part you see here is not used by Zabbix. It's because we share it with Eltele, so web hosting solution. The backend, pretty much the same principle. Dual SQL servers, Zabbix servers, active standby setup, and of course the proxies. This is the live map, and I made the links. So this map will show where the active roles of each individual component is. External factors in your data centers. So what kind of factors are we talking about? Well, of course, there's temperature. I don't need to explain to anyone. High temperature is bad. Worth noting, though, probably also know, but what is worse than high temperatures is temperature that fluctuates. And the reason for that is the silicon in your circuitries gets heated up and cooled down, heated up, expanding, retracting, expanding, retracting. It will cause a tremendous amount of stress to the equipment and then lowering the lifespan. Humidity, also a no-brainer. I will explain in detail on a coming example, but rule of thumb, the higher the humidity, the faster and higher risk of corrosion. Light. Light used to be more interesting to measure before because we used it to discover where power was wasted, where are the lights on. Today, it's getting less interesting because everyone is moving to LED-based lighting and it doesn't use much power. In addition to that, a simple light sensor can have purpose as a cheap presence detection. Someone enters a dark room, they will switch on the lights, and we have a log. Someone was there. Or, of course, if you use a less cheap light sensor, you can measure lux values and see that the conditions in an office environment is up to HMS standards. Contact, that is typically opening doors and windows, or water leaks. Could be a lot of things. Anything that puts two pieces together, like a door, for example. Smoke, fire. Is there anyone in this room who is not monitoring smoke or fire in your data centers already? Motion, be it by infrared motion detectors or security cameras, is all security related. You get this. I was a bit unsure if I wanted to take this slide, being a very much technical conference and everything, but just for the sales argument, why are we monitoring? Well, of course, to avoid downtime. But just to put some numbers on it, the top 4 reasons for failures in electronic equipment, the top 4, the percentages are divided between temperature by a large margin, vibration, humidity, and dust. Dust also adding to the temperature problem. Now, there's not much we can do about vibrations. In most cases, it's not interesting either, because we don't live in an area with random earthquakes. Or it's just going to be ridiculously expensive, and if it shakes, it shakes. We can't prevent it. So, disregarding vibrations, with Zabbix, specialized hardware and some proactive thinking, we can avoid 80% of the top 4 reasons for failure and downtime. Most customers buy that argument. Of course, in addition to these 4, with probability, depending on your location and scenario, fire, theft, water leak detection, and so on, could also be considered. So, a few examples of what kind of data can we gather and how can we interpret this in Zabbix. What you see here is a rather, well, less than ideal situation for any data center. We're measuring temperature on the inside and on the outside. Red being inside, green at the top being outside, as well as light, but on the inside of the data center. The time span here is exactly 1 month. And for those who want to count, there are exactly 30 blue spikes, 30 light spikes. So what does that mean? Daylight, of course. And you're right, we're measuring on the inside, so we're talking about windows here involved. So the light obviously drives the temperature, mostly outside, but also on the inside. You see the same spikes are pushing on each other all the way up. So from this graph alone, with these factors, I know that this data center should be better isolated and have their window shaded. Simple measures. A little bit more in depth about humidity. Question: how safe are these levels? First, most of you have probably noticed the technical specification for any component or complete server or whatever we have bought. It says operating humidity range. Usually something like 5 to 95% relative humidity, non-condensing. So quick question, we're lying here at around closely 40% humidity. And 10 degrees. So, are these levels safe? Well, the part about non-condensing on the technical specification is vital. Anything above 95% is condensing, period. So that's fine, but it says 5 to 95. But condensation happens when heat meets cold with a perfect amount of humidity combined. So there's a great web page, dpcalc.com. For your own environment, you can check that and see what kind of conditions are necessary to make tiny raindrops in your data room. So, question to the answer: how safe? At 10 degrees Celsius and a 40% humidity, condensations would appear at a sudden drop to 3 degrees. And that is highly likely where I live. I like this example. I used it on the blog as well. It shows a switch room at a customer of ours. It's a rather small room. It contains a bunch of power over Ethernet switches. Quickly gets hot in there. So, of course, they have air conditioning, but it's a floor-standing, buy-off-the-shelf Walmart type of equipment. It works, but we don't trust it. So, monitoring. The first half of the graph, from left to middle right, that is the current baseline. That is a normal situation. We see some fluctuating. Temperature is gradually rising a little bit, going down, up, down, down, and that's normal, as well as the humidity. Humidity is a bit more violent. But these readings are due to the thermostat kicking in, cooling down, being satisfied, and then turns off. So hence this pattern. Then we come into the middle. We have that nasty gap that none of us likes. It just starts responding. Got an alarm, sensor offline. Okay, but we didn't really have time to react before it started answering again. And it continued. The graphing continued. Humidity went down. Temperature went way up. Eventually hit the threshold and sent us an alert. And what happened there was power came back on. It was just a random outage. Nobody turned off the power. It just went away and came back. So the floor standing air conditioner had to be turned on manually. We got the customer out on the site, turning it back on, and that's when the red line starts to drop again, creating a new baseline, slightly different threshold. You see it's way higher, but that's because you have to manually adjust below 22 degrees, which is the factory default. But still fine, we're below the threshold. Now you can imagine a similar scenario with 40 freezers in a large grocery store. This happening at night. Everything gets thawed. But later that night, power comes back on. It freezes down again. who knows that all the food in the entire store is damaged? Yeah. And a few lawyers afterwards. Right, moving on. So, at Eltele, of course, we have some data centers, this being one of them. This is a normal day at the office. We have all green, OK trigger states. We're having temperature sensors at both air conditioners. It's really fussy, sorry. We have a magnet switch on the door, so we know if anyone walks through it, no matter how fast they go. Motion detector up in the corner, IP camera, and ambient room temperature. So again, this is a normal day at the office. Everyone, facility manager is watching this all day, is all happy, and then goes home. But later that night, a competitor managed to to sneak in, to steal a power cord to one of the air conditioners, which it trips in, smashes into the floor, and bleeds out. This did not happen for real, by the way. But the result, we got the door penetration alarm first, naturally. Then motion detector caught him. We can see it from the screenshot because this was taken a bit later. Third, water detector picked up the blood. And a few minutes later, as you also can see from the graphs, temperatures in the room, the ambient room temperature, as well as the air conditioner, which reached the same temperature. That's the alarm threshold for the air conditioners. As well as a couple of sensors in rack 4, all goes off. So, another map-based example, pretty much the same as the previous one, but in a more two-dimensional large building overview. It's probably unreadable, but every room has a transparent PNG icon with just a label that has the latest temperature, humidity, and light reading. If it's a motion sensor in one of the rooms, that will also be on the map. But again, transparent PNGs for any OK trigger or hosts. But as soon as something happens, it goes into problem state, it would turn into a big yellow exclamation mark like that to clearly catch your attention if something is off. Last example, complete dashboard. This is just a screen consisting of a map for the header, a couple of graphs to have historic data of temperature and humidity in this case. And we also have a few other components you might not have seen before. The cake diagram to the left. Just to have a side-by-side comparison of all the rooms. And the way the pies in this diagram is shaped, I would say the building ventilation is working perfectly. As well as a few key performance indicator to the right, the speedometer gauges. At the bottom, a list of active alarms. Currently, the data center is slightly above threshold, so that's mentioned. IP camera is offline, listed. The examples, the speedometer gauges and the pie chart, cake diagram, it's just Google visualization code I made a separate web page, just querying the database directly, getting what it wants, and have it included in a single cell. Basic hacks. So, before we move on to some live demo, any questions?
How do you make this 3D view of your data centers?
The 3D room. That particular one was made with an online web-based. Oh, sorry. That map of the data center was created with an online editing tool called Floor Planner. Floorplanner.com.
Looks very impressive.
Sorry?
Looks very impressive. Looks very impressive.
Thank you.
Hello. Hello.
Hi.
Hi. How were you able to keep this kind of information? You have made a small device to monitoring temperature, humidity, and other sensor. You have created some small appliance.
The devices I use to gather this information, if that's what you're asking about.
Yes.
I actually forgot to include my own company in
okay.
the presentation. In addition to working at Eltele, I personally own my own company. It's called Sensorfabrikken. It's a Norwegian company.
I know.
Roughly translated to the sensor factory. That company produces and programs these environmental sensors.
Okay. Thank you.
And how do you connect these sensors together? They are all connected to internet or some like other sensor networks to some sensor hub or device or system?
I don't want to get too technical with the sensors right here because it's very specific, but yes, they are internet connected. They talk TCP/IP. The standard protocol is SNMP. You can also retrieve values by HTTP or TTL level serial interface if you're into that kind of stuff.
And this last screen showed these nice gauges. This was from taken as an iframe from some other monitoring software.
No, it's all Zabbix except the Google visualization component, which is not a different monitoring software. It's just a framework to create graphs and data representations.
Thank you.
Do we have more questions? Okay, so let's move on to demo then.
I'll try to keep this short, but best resolution in the world here.
Sergey?
No, we couldn't fix it. We tried. All right, so I connected some equipment here. Random mess of cables. We are measuring a few different parameters like temperature and humidity in one box. Sensor alone measuring temperature, as well as light intensity, and a water leak detector, as well as a door sensor, which is basically just a magnet switch, and a motion sensor. So, just to keep it quiet, I made a switch to enable the triggers in Zabbix, it's basically connected to the same sensors. So we read the sensor, we know that these pins are active, and as long as they are, and some critical threshold has been met, a disaster alarm will fire. So if you guys on the front row will be sit still. Just gonna wait for the buttons to kick in. There we go. We have all three. So if any motion would appear, any doors would be opened, or yeah, if anything would happen right now, an alarm would fire. You think the hotel will forgive me if I mess up the floor?
Go for it. I guess yes. Yes, you can.
So we have a wall leak detector. Jamming it good in there. Polling interval is, of course, a factor in this. But we already have it. It's red. Water leak detected. Pretty much the same with the door sensor. Let's kick this door open. At the same time, measuring humidity. Can you guys read that?
No, read it for us. It says door open.
Better? Alright.
Can you make it alcohol level in the room?
That was a motion detector. For those who can't see it, it's the red blinking infrared detector lying in front there. Last test. Could someone be kind to get me a cup of coffee? And don't be skeptical. Is it warm? It's not 100% waterproof, so it'll be okay. At the same time, Sergey? I'm just going to remove that water sensor to clear out the graph. So this big red graph over here is the wired temperature sensor I just inserted into a cup of half warm, but we still got results. Same pattern you would see, perhaps a little bit slower descending if any air conditioner went out. Hit the lights, please. Rapid change in light. So at the same time, we'll see the blue part of the graph is the water. I should have pulled it out earlier, but the yellow one that is dropped to half. That seems about right. Yeah. And of course, the case of bad breath over here. Can probably turn it back on. Right, I think I demonstrated mostly everything. If anyone, I think I have a little bit of time. So, and if there are any questions now.
Can I take my coffee?
Yeah, sure.
Temperature sensor in it.
It's not food safe material, that one. Sorry. I got you a new one.
If anyone wants coffee with temperature sensor in it.
I just wanted to ask a little question about practical approach. If you have a lot of sensors, there are usually some noise in the data, some missing values or some spikes which are not reflecting the reality of environment. How do you fight with such data? It's, let's say, a sensor for a few months, it gives one no data value or some spike, unexplainable.
No data. There's not much I can do about that.
Yes.
But that's because the sensor is unavailable. If you set a polling interval that is 1 hour, you will get a clean graph, of course.
So this is processed in sensors already.
Yeah.
How do you do it? You are averaging, or how do you process this data on these sensors? Just curious.
Well, it's a combination. Is anyone else interested in this? Because I feel I'm advertising right now.
Okay.
By all means, I can tell you all about the technical bits and pieces of these sensors, but I would prefer it if we took it in the bar. It's about the concept and how to make Zabbix work with external hardware sensors. And it doesn't matter if it's mine or if it's well, any kind. I tried a few, most of them works great. I made mine. It's the principle and results.
Do you have any experience with like small, really small vibrations? Because for normal disks, normal hard disks, the latency increases. There is a YouTube movie from it, shouting at servers.
Yeah. I've tried vibration sensors, so I can get an actual graph out of it. But mostly, I work primarily in a data center environment, and all these kind of factors are already accounted for. So we buy complete hardware, and they are just up to the specs. They know that disk will vibrate, and they have compensated for it, so it shouldn't. But the kind of hardware you're talking about might not be, and I might be mistaken as well, might not be the best place to invest in external monitoring hardware.
It's just curiosity. So.
Yeah, but I know what you're talking about. But it's just that it's not a factor in all my customer cases.
So do you have more questions? Well then, thank you very much. You guys are so more interesting.